Do, 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 do. Do, 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 do. All right, I think I am live, so I don't know if I don't think anybody's watching, which is fine. Do, do, do. Ba-da-da-da-da. Ba-da-da-da-da. All right, just trying to get my desktop all set up here. I have this mostly off-screen part here so people don't have to see my chat windows because nobody wants to see that. All the terribly inappropriate things I say. I don't really say inappropriate things. I wonder if I have the chat set up right here. This is just a test chat. Okay. Very, very cool. Looks like it went to all the platforms as well. Very nice. Very, very nice. Who wants a cubicle? All right, let's listen to some questionable quality training about what I'm teaching.
Hello everyone and welcome back. In this module, we will understand the cloud load balancing service of Google Cloud. Let's quickly understand what load balancer is. A load balancer distributes user traffic.
I know what it is.
These load balancers are available as either proxy load balancer implemented by using Andromeda virtual networking and Google maglev technology. As the name suggests, these load balancers are not for call traffic. These load balancers are available as either proxy load balancers or pass-through load balancers. You can pick a load balancers depending on the needs of your applications and the type of traffic that it needs to handle. Let's look at the proxy network load balancer. Again, as I said, these are layer 4 reverse proxy load balancers that distribute TCP traffic to virtual machines instances in your Google Cloud VPC network. Traffic is terminated at the load balancing layer and then forwarded to the closest available backend by using TCP. These load balancers are implemented as managed services on GFE.
Ugh, okay. Man, My job is just, to make load balancing exciting. All right, let's look at the actual thing. Load balancing, availability of resource locations in a network, and network service tiers. All right, well, the network service tiers I've covered before. Load balancing, Google Cloud platform. Wow, just got really dizzy. Let's see all the load balancing products available. Oof. Wow. Dwayne, I will try not to test too hard, yeah. Wow. That is just a loaded bullet point there. All right. Well, load balancing is going to be the bulk of this, clearly. So we have service tiers, availability of resources, availability of resource locations in a network. I don't even know what that means. Okay. Ant, I don't know what I said, but I wouldn't doubt it if it was. Resource locations. What does that mean? Well, yeah, I see all that. It's nice. The only Google results are just like copies of the actual objectives list. All right, fine. Resource locations. Okay, how about load balancing? Before adding a resource location constraint, right. Oh, You can. I should probably set this to away. Location types, different size categories. The largest location type is multi-region. Each region is divided into zones. Yeah, we know about zones and regions. Okay. When setting up locations, you should use the in. Okay. What does that have to do with the price of rice in China? No, what does it have to do? Availability of resource locations in a network. Okay. How do we... Wow. I just may not know the answer to this. Oh, no. Be resource manager and resource hierarchy.
Hello and welcome everybody.
Well, thank you.
Let's go ahead and chat about Google Cloud Resource Manager and Resource Hierarchy.
Oh, I don't really want to.
Resource Manager helps you structure your cloud resources, also manages your access control, and implements policies across your entire organization. Let's go step by step. What is Resource Manager? Resource Manager is Google Cloud service for centrally managing your cloud resources. It gives you various tools to organize, manage access controls, and also enforce policies. You can apply policies to projects and folders to enforce organization-wide rules.
So
a resource hierarchy is like a family tree for your resources. It's structured as follows. So you got
organization folders. This is not no.
So you got organization at the top level and
no. That has nothing to do with networking. Let's see. All right. That is no help. All right. Nope. Availability of resource locations in a network. Availability of resource locations in a network. I would understand. Okay. All right. Let's just go to where's network? Oh, VPC network, I guess. Fine. Oh my gosh. Okay, no. We'll not use this. Okay. Now let's go to networking, I guess. Oh, this is not what I want. Networking. Network management tools. Okay, let's do that one. Oh, here we go. Load balancers. All right. No. I'll tell you what. Google Cloud. Very frustrating. One of the toughest parts is there's a lot of training out there, and none of it is great. No. Let's see. Origin. Oh, I bet that's what we're talking. So let's set up just a network load balancer. Oh boy, I gotta learn all about the different options, don't I? Wow. Okay, so I can pick a region. For me, it's going to be central. I don't have an instance group. Well, certainly need an instance group. What is an instance group? Why, that's a great question. I have no idea what I'm doing. Oh, gosh. All right. Yeah, let's just cancel this. Oh boy, oh boy, oh boy. See, this is not about virtual private clouds, though. I don't need to know about that yet.
In this lecture, we will explore how IP addresses work in GCP. In Google Cloud Platform, you can assign an IP address to certain resources. IP addresses allow resources to identify and communicate with other resources. There are many types and they have different uses. For example, you can assign an internal and external IP address to the compute engine virtual machine, or you can assign an internal or external IP address to the forwarding rule used for load balancing. Each VM instance can have one primary internal IP address, one or more secondary IP addresses, and one external IP address. The internal IP addresses are used for communication within the GCP VPC network, and the external IP address is used for communication outside the VPC and the world. The external and internal IP address can be either ephemeral or static. Every VPC instance can have one primary internal IP address that's unique to the VPC network. You can assign a specific internal IP address when you create a VM instance, or you can reserve a static internal IP address for your project and assign that address to the resource. If your network is in the auto mode VPC network, then the address comes from the region's subnet. If your network is custom mode, then you must specify which subnet the IP address will come from. If your network is a legacy network, the IP address is assigned from the network's global internal IP range, or static. Every VPC instance can have one primary internal IP address that's unique to the VPC network. You can assign a specific internal IP address when you create a VM instance, or you can reserve a static internal IP address, primary internal IP address, one or more secondary IP addresses, and one external IP address. The internal IP addresses are used for communication within the GCP VPC network, and the external IP address is used for communication outside the VPC and the world. The external and internal IP address
Okay.
of zones within the subnet the IP address will come from.
So VPC, they're just talking about the internal network. Okay, I guess. Oh, virtual private cloud network. Okay, let me just listen to what he has to say here.
Hello everyone and welcome back. In this module, we will explore the fundamentals of virtual private cloud VPC on Google Cloud. It provides a private network segment within a shared resources of a public cloud, offering increased security and control compared to using the public internet. Think of it as a dedicated network segment carved out within the large public cloud, allowing you to build and manage your own private network environment that consists of a list of regional virtual subnetworks of a subnet and data centers, all connected by a global wide area network. VPC networks are logically isolated from each other in Google Cloud. Let's understand all the things that VPC network does for us. It provides connectivity for your compute engine virtual machine instances, offers native internal pass-through network load balancers and proxy systems for internal application load balancing, connects to on-premises networks like
Right, but I don't. I think that's just okay. All right, where is compute engine? Isn't that just? Oh, instance groups. Okay. What is that? Migrate to virtual machines. From what? Use the migrate to virtual to program migrate workloads. All right, I have no idea what that means. Disk storage pulls images. Not bare metal. No, settings, I guess. I feel like networking should be in here. Oh, networks, there we go. But that's bare metal solution. I want bare metal solutions. All right, let's just create one. Create instance there. Zone any is fine. Go E2 micro, that'll be free. Standard. Networking. Network interfaces. Here, this is where, okay, here. Network. Thanks. Where is that? Is that just, where did I set that up? I mean, it looks pretty standard. And then this is external, but network. Yeah, I know what it means. Different subnetworks can communicate internal IPs along the same network. Okay, I understand how networking works, but where is that supposed to be configured? 10.128.0.0. Storage pools, snapshots, instance groups. See, I get that, but this is bare metal solutions. I don't want, I don't want bare metal solutions anyway. Metadata zones, maybe network endpoint groups. This is redonkulous. I just want to understand. I don't want a virtual private cloud. Maybe that's where it's located, though. Doesn't appear so. Internal. Okay. Yeah, I guess I'll enable the network connectivity API. What a pain in the butt. Of course, there's no internal ranges. The default, okay. All right, where did it say default? I don't know what that means. Like happened. Oh. Well, thank you, Gyro. I didn't know that was set up. That was fancy noises. Cool. All right. This page describes a VPC network as different from legacy networks. Legacy networks can no longer be created and are not recommended for production because they do not support advanced networking features. You can convert a legacy network to a VPC network. To see your existing network type, view network. See, I tried to view networks, but I didn't think that it took me to a place. Oh, a virtual private cloud again. All right. Maybe all networks are now there. Yes, I know what networks and subnetworks are. A subnet is not the same thing as a VPC network. Networks and subnets are different types of resources. Well, good, because they're different things. Virtual machine instances. The virtual machines hosted on Google's infrastructure. VM instance, VM are synonymous. Great. VPC networks have the following properties. VPC networks, including their associated rules, are global resource. They're not associated with any particular region or zone. Oh, that's interesting. Subnets are regional resources. Okay. Each subnet defines a range of IP addresses. Traffic to and from instances can be controlled with network firewall rules. Rules are implemented on the VMs themselves, so traffic can be controlled and logged as it leaves and arrives at a VM. Resources within a VPC network can communicate with one another by using internal addresses subject to applicable firewall rules. Yes, yes. Google APIs. Network administration, rules, and organization. Use a shared VPC to keep a VPC network in common host project. Authorized IAM principles. Okay. Okay. Subnet 1. Yeah. Okay, so subnets have a region. What about zones? Subnet 2 is in region east. 2 VM instances in B zone are in the subnet. Their IP addresses both come from the available range of addresses in subnet 2. Okay, so in B, zone US1B, east, oh, these are both in there, okay. So all the zones in a region can be in the same subnet, but they don't have to be. So a subnet is in a region, not in a zone. And as long as, oh wait, no, because this shows a subnet is just in these 2 zones. It's not over here. Wait, where's subnet 3? Oh, subnet 3. Oh, so 1 VM instance in zone B. Hey, thanks, Ryan. 1 zone B is a second instance, and C are both in subnet 3, each receiving IP address from its available range. Because subnets are regional resources, not zonal, instances can have their network interfaces associated with any subnet in the same region that contains their zones. Okay. So a subnet is a regional thing. Awesome. But in auto mode, VPC network is 1 subnet from each region is automatically created within it. Automatically created subnets and predefined it fits with, oh. Google Cloud offers 2 types of VPC networks determined by their subnet creation mode. When in auto mode VPC, so everything is a VPC network. Well, that, and legacy is no longer a thing. Okay, great. But when you say virtual private cloud, that insinuates it's not in the public cloud. Okay, whatever. Terminology is terminology. That is why I'm a trainer. These automatically create subnets. Let's see. These automatically create subnets in those regions automatically added to high samples and tests. In addition to the automatically created subnets. Ryan, I'm working on Google Cloud Platform. This is my day job, making training videos for CBT Nuggets. And I am not a cloudy guy, so I understand I understand the concepts involved with computing and just trying to apply that to, oh, thank you, Gyro. I appreciate that. Trying to apply that knowledge to what it means in the Google Cloud is frustrating. Things like VPC is a virtual private cloud, but a VPC network is the only kind of internal network there is, even though there used to be something else apparently in Google, and now there's not. So it's just, yeah, I'm just trying to sort out the information so that I can make training that is clear. But yeah, this won't be on YouTube. This is all for CBT Nuggets. Okay. These automatically created subnets are a set of predefined ranges that fit within 10.128.00/9. Man, what is /9? I would understand if it was /8. I don't know what the 9 gives us. Anyway, as new Google Cloud regions become available, new subnets in those regions are automatically added to auto mode VPC networks by using an IP range from that block. Okay, in addition to the automatically generated or created subnets, you can add more subnets manually in auto mode that you choose by using IP ranges outside of that. Okay. All right. On a custom mode, no subnets are automatically created. This type of network provides you with complete control over its subnets and IP ranges. You decide which subnets to create in regions that you choose by using IP ranges that you specify. That's fine. I mean, okay. You can switch a VPC network from auto mode to custom mode. This is a one-way conversion. Custom mode VPC networks cannot be changed to auto mode VPC networks. Decide which consideration for auto mode. Okay, here we go. Unless you choose to disable it, each new project starts with a default network. The default network is an auto mode VPC network with pre-populated IP version 4 firewall rules. The default network does not have pre-populated IPs version 6. That's fine. Auto mode VPC networks are easy to set up and use, and they're well suited in use cases, having subnets automatically created in each region. Yes, that I agree. So each region has its own subnet. The predefined IP ranges of the subnets do not overlap with IP ranges that you would use for different purposes. For example, cloud VPN connections to on-premises resources. Oh, right. Yeah, if I'm using 10.128, that would not be good. However, are more flexible? Yes, I understand that. What if every range has 10.128.0.0? How? Okay, I don't understand how that would work. So let's go to, it doesn't even show it. Oh, it does. Whoa, VPC networks, default. Okay. It's an auto mode. And it has, oh, it's the 128 was just coincidence. So, if anybody's trying to follow along with my nonsense here, when I created the container or the instance, the virtual machine, and I chose a default network, it used the IP range of 10.128 dot something, and that happens to be the exact example range that they used when they describe stuff here. But they have automatically made every region have its own range. No, it can't be .9, right? Oh no, that's what they're saying. Oh, because, okay, let's see. So the default in hide info panel. Okay. Yeah, it's /20. So everything in 10.128, that's what the /9 comes in. Instead of /8 would be 10.0.0.0. /9 is 10.128. So anything before that. Okay. Okay. I understand now. Sort of. Yeah, and US Central is the first one, 10.128.0.0. So can I sort by? Yeah, that just happens to be, the one that I'm using happens to be the first one that they've chopped up. So the the second half of the 10 dot domain or subnets, they're all already assigned to these regions. Okay. So the region doesn't have a /9 subnet. The region has a /20, which probably, are they all /20? Yeah. So that probably gives it what? 4? Let's see, 28, 29, 30, 31. Yeah. Okay. All right. It's becoming a little clearer. Hey, welcome. Jacob, welcome. Yeah, it's great to see people here. And again, this is, if you're here for entertainment, I apologize. Other than seeing me struggle, if that is entertaining, then hey, cool beans. But yeah. You know what? I'm gonna see if. So it looks like the little how many people are watching from where thing is accurate on the top. I want to see. Let me go to We'll just do it right here on screen. Go to youtube.com. I think I just called it Brain of Sean. Nope. Maybe the Brain of Sean? So, yeah. And he's live.
I'll just do it right here on screen.
Okay, mute this. That's going to get annoying, yeah. All right. We'll see if that pops up on the how many people are watching. Because I don't know. For me, it still shows that it's just a couple. Maybe it doesn't count if I'm not an actual person here. It should count. I'm watching. Do I have to have an account? All right. Sean CBT Ace is going to create an account. Yeah. All right, come on. No, go back to where it was. Silly rabbit. All right, here we go. Test from myself. Uh-oh. Did it go? Oh, yeah, it showed. Test for myself. Cool. But it still doesn't show that I'm a person on the top of the screen there. I wonder why. Maybe it takes it a minute. All right, we're just going to leave that going in the background. Now, back to my understanding of the networks. Everything is a VPC. Everything is a VPC. Everything is a VPC. I guess that's the. Let's make that a. Oh wait, what are my things here? Load balancing, availability of resource locations in a network. I still don't understand what that is even saying. Availability of resource locations in a network. I'll figure it out eventually. But first off, all right. Because I found that very confusing, so. Availability of resource locations in a network. If I can't figure out what that means, I'm just going to go with the whole thing I just learned about VPCs and the default automatic one. Because, oh no, oh, it's over here. Because otherwise, that's just. Yep. Anything in this region. Oh, but see, all of these addresses are not auto. These are all manual. We know that because 10.2 is not part of the automatic range. Up here, 10.240 is. So this is region US West. This is a subnet that exists there. But if I create a subnet in region US West of like 10.1, that means that I could not create the same subnet 10.1 in region US East, because it should tell me you can't do that. That range is already used. Let's try that. Let's try to break it. And then that will be an example that I use when I try to break it. Yeah, okay, create a VPC network. Oh, that's disappointing. I mean, Facebook, I don't know. I know a lot of people on Facebook, and I think I'm streaming to the my Facebook, like the public persona of Sean, as opposed to my personal Facebook page. So I'm not positive there, but it is a little frustrating because I'm using Restream, so there shouldn't be like a terrible delay, as long as it should be the same delay from one to the other. I don't know. Also, I still don't see myself being shown on that little thingy up there. Although, so I do show that I have 7 people watching. Oh, okay. And you probably can't see here. Do you want to see what I see? Do you see what I see? I'm sure this is going to be weirdly hard to see. But I don't know if I can even do this. So up here, if I click on this, it shows how many people are watching on one platform. So on Twitch, there's 3 people watching. That is correct. On Sean Power's Facebook page, 1 person is watching. So that lines up with the little graphic deal. But inside Brain of Sean, 2 people are watching, and that did not line up. So that is a big stinker. And that widget, see, I'm going on a little bunny trail because this whole VPC thing is driving me nuts. So I'm going to be a bad influence here and just kind of bunny trail a little bit. Let's go to my, oh, that's where I'm already here. Okay, so this is my, let's go to Streamlabs. All right, no, I just want to log in. Oh, dashboard, I'm already logged in. All right. Let's see. All widgets, I guess. Viewer count. Okay, viewer count. So, yeah. YouTube viewers, Facebook viewers. So, undo that. Save settings. Okay, disappeared in real time. That was cool. And I'll do that. Click Save Settings. And it went back. Aha, there. Now it is showing the right one. Oh, okay. I wonder if it'll ever get Twitch back. Nonetheless, that looks like it was correct. So, okay. I don't know why. Yeah, okay. Okay, cool. I didn't change anything. I just unchecked and rechecked. But the issue is I changed which YouTube account it was using. So it must have been using my other YouTube, because I'm just going to my vlog inside the Brain of Sean YouTube channel. But anyway, now it looks right. 3, 2, 1. And that looks about right. It thinks there's 1 person there. So yeah, I'm going to call that good. All right. Back to work, Sean. More coffee. Okay. We were going to try to mess something up so that we can then again mess it up. Overlapper is what we're going to call this network, because we're going to try to make it so that it infringes on 2 different, like across 2 regions. All right, let's see. Description. Trying to break it. Not break it like that. Break it. All right. Subnet is going to be custom. Yes. Okay. Oh, wait. I'm creating a new network. Okay. A network goes across regions. Okay. And there's going to be a new subnet in it. And I'm going to name this subnet 10, 1. Wait, does it have to be no spaces? 1, 10.11. Okay. And the region is going to be, just for fun, US Central. Okay. IP range is going to be 10. What did I call it? 10.1.1.024. Okay. All right. What is private Google access? Whether the VMs in the subnet can access Google services without extent. Oh. Select whether VMs in this network can access Google services without assigning external IP addresses. But on and off doesn't make sense. Private Google address, like private inside so that it can access Google services, or private from Google access. That's not clear. All right, whatever. Flow logs, I don't even know. What is a hybrid subnet? Modifies the VPC network routing to overlap between the subnet's IP address range and those of custom dynamic routes. Allow hybrid subnet modifies. Oh, allowing hybrid subnet modifies the virtual private network routing behavior to allow overlap between the subnet's IP address range and those of custom dynamic routes. Sure. All right. So 10.11 exists in a certain region. Okay. Can I save this? Do I have to? Okay, I'm just going to save it. Yeah, create this. Okay. Yay. Oh, thank you, Michelle. All right. Come on, create it, because I don't want to edit it, and I want to try to edit it in a wrong way. Here we go now. Hurry, make that network. How hard is it to make a network? I have no idea how hard it is, but okay. So overlapper. Now let's edit this network. Cloud routers will learn routes only in the region in which they're created, or let you dynamically learn routes to and from all regions within a single VPN. Okay, I have no idea. Sunstruggle, thank you for following me on Twitch. You are getting me closer to affiliate. And I don't know if I talked about, I think I did talk about affiliate stuff, why I'm doing that. Best path selection, I don't care about that. Oh, subnets, here we go. Okay, I'm just going to leave everything here default, but subnets. Uh-oh. Edit mode is active. Yeah, so why can't I? Why can't I edit? Yeah, edit mode is active. I want to edit it. Oh, I see. Subnets are not considered editing. Good to know. All right, so now what I'm going to try to do to break this, I'm just saying this out loud for myself. No, wait. The name is overlapper. Oh, wait, I have to pick one? Is that? Like I had to. No. The name of the subnet. Okay. 10.1.1 again. Description, working it. Oh, it's already in the VPC network overlapper. So region now is going to be, the first one was US Central 1. So now I'm going to do US East 1. The purpose. Oh, there's a lot to learn. Yeah, I'm just going to say there's no reason. Okay, let's try 10. What was it? 1.1, right? 1.1.024. Okay. Oh, yes. Ha ha ha. Okay. Perfect. What if I did, oh, it should still say overlap if I do like 1 and 32. Oh, okay. 29. It overlaps. Perfect. All right, that makes me happy. So I can't, yeah, that kind of follows with exactly what they said is true about subnets. The network is global. The subnet within the network has to stay within the region. Okay. Now I wonder, how does route, I bet that's stuff I still don't understand. If there's a network, if everybody is in the same network, but they're in different subnets, do they route between subnets? Routes. Select the region. You want to view. No, I didn't want to see routes in a specific region. I bet that was a dynamic routing model. Oh, this is it. Only in the region they are created, or learn routes from all regions with a single VPN or interconnecting cloud router. Okay, I bet. Oh, how clients in a network connected using cloud VPN or cloud interconnect can access the internal load balancer. All right, yeah, that's a bigger question, but at least I bet that's the whole deal there. The algorithm needs to remove the path forwarding. Okay. Okay, cool. Oh, wait, that was right in there. I could delete it. Delete VPC network. Also deletes the yeah. Type the name overlapper. All right. That demo is going to be in this skill. And you know what? I'm thinking more and more that, where was it? Availability of resource locations in a network. I still don't really know what that means. Availability of resource locations in a network. Huh. Network service tiers I actually covered before, so I'll go over that. All right. All right, let's see. Wait, what did all they want? Oh, load balancing. I mean, that's a huge topic, and we have to talk about that later, right? Let's see. Running cloud solution. Machines, network resources. See, this is the same stuff though. So down here, deploying and implementing network resources, creating a VPC with subnets, which we actually just figured out, custom mode and shared, custom mode VPC or a shared VPC? What does shared VPC mean? That doesn't make any sense. There's custom mode and auto mode, not shared mode. Creating ingress and egress firewall rules. Okay, so that's bigger. Peering external networks, VPN network peering, cloud VPN. Yeah, that's big, but this feels okay. Snapshots, images, cluster, node pools. Ooh, Kubernetes stuff is going to be a pain in the butt. Creation, application splitting, storage. We already covered storage. It's going to be more in depth. Network resources. Again, adding a subnet to an existing VPC. Again, why is this the third time now we're going to cover that? Expanding a subnet to have more IP addresses. Okay, that feels more like networking 101, but reserving static external or internal. Okay. Or the cloud DNS and cloud NAT. Access accounts. Okay, it really doesn't talk about load balancing anywhere else, does it? Just up top here? Planning and configuring network resources. Load balancing. So much needs to be learned, though, before we can cover that. So bizarre. All right. Everything is a VPC. And then now before that, I want to talk about oh shoot, what'd they call it? Network service tiers. Next video question. Okay, because network service tiers are just talking about the I don't know if it's just for virtual machines, but it is for virtual machines, so we can definitely learn about it there. All right. Oh, you know what we should do? Let's go to Cloud Engineer. All right. They have exam guide is what we looked at. Take a webinar? No. Complete preparing for, okay. Is this the, yeah. Okay. Preparing for your associate cloud engineer journey. Cloud solution environment. What is the, all right, no, let's go back. I said cloud solution environment. Is that, okay, no, we're in planning and configuring a cloud solution. Okay. Okay, so.
Welcome to Module 2, Planning and Configuring Cloud Solutions.
Okay.
In this module, you'll explore the scope of tasks involved in planning and configuring Symbol Superstore's cloud solutions, which corresponds to the second section of the Associate Cloud Engineer Exam Guide. We'll start by discussing some considerations for how you would decide the kinds of resources needed for Symbol Superstore's application requirements.
That's not what I want, though.
You'll assess your skills in this section through 10 diagnostic questions. Then we'll review these questions. Based on the areas you need to learn more about, you'll identify resources to include in your study plan.
Oh, well, that's dumb.
Let's discuss how to evaluate Symbol Superstore's existing applications so we can plan and configure a cloud solution for them. The first planning meeting for Symbol Superstore's migration to Google Cloud was a success. Everyone is excited to get into the details of how Symbol.
So what, this is just a. .4 isn't even a. There is no 2.4. You sneaky sneakers. All right, let's see. Yeah, I've already looked at all that. I want to know about storage classes. No, we already did all that too. Okay, no questions. Okay, here we go. Google VPC is load balancing. Oh. So this isn't necessarily a how-to. This is an explanation as to... Oh, well, that's lame. That's so much simpler. That doesn't actually answer my question, though, about... Load balancing was just one part. Oh, here we go. Okay. Help you build. Okay. No. Oh. Big poo-poo heads. All right. Well, I mean, I guess this information is nice to see. It's from Google, so that's cool. Oh, I could download this. Wait, I don't want to download it. Can I zoom in on it? Make it... Okay, I bigified it. Okay, so I can shrinkify the rest of it and just growify it. There we go. All right. All right, and then I am going to a screenshot of this because that's useful. Save as. No, we are in 2.3. Planning and configuring networking options. Ba-dum-bum. Balancer summary from Goog. Hey. And then... No, I don't care about questions. No, 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 no. Wow. Okay, just gonna save this for myself. Yes. Hey. Wonderful. All right, I guess that's interesting, but not what I was hoping for. Because I still don't know what availability of resource locations in a network means. Availability of resource locations. What is... Nope, I don't know what that was. think I was here before. Resource locations. The resources used by each service are impacted by location in different ways. Before adding a resource location constraint, review the appropriate section to see how the resources you are applying the policy will, okay. Resource locations in a network. Let's look for VPC. When personally created instance of region. Regional location constraints don't apply to VPC networks because they are global resources. Resource location constraints are enforced on subnetworks at the time of the creation. If you create an auto mode, subnets are created only in the regions that are allowed by the resource location constraint. Okay, so is that just a really crappy way of saying how subnets are resource locations in a network? I'm just going to assume that's talking about how subnets and regions and zones and global stuff works. So we are just going to assume that's what that means, because I don't see any other teaching in any of the other stuff about something about resource locations in a network apart from how regions and zones and global works with regard to networking. So that's what we're going to cover. So network service tiers, that has to do with how a VM gets treated with regard to how it exits the Google Cloud. We covered that, but I'll cover it again because it's specifically mentioned there. You know what? Did I compute? You know what? I didn't have to cover that up in 2.1, and I did. So definitely cover it in more detail here. All right, so I'm going to go backwards. Start with network service tiers, then availability of resource locations in a network, and then load balancing, which I still don't understand. Okay. Perfect. All right. Hey, everybody who's just kind of hanging along with me, thank you. I appreciate it. Oh, look how close we're getting to 50 followers. That's awesome. I have no idea how quickly the affiliate process will go. I have to get 50 followers, and then I have to stream so many hours a month, and I have to have an average of 3 viewers per live stream, which currently we have 3 viewers, Twitch viewers. We'll see how that goes. Everything is a VPC. All right, and then I got to learn more about load balancing before I can. All right. Let's go to the zoo. No. Go to networking. Yeah, the virtual private. I got that. This is a lot of peering. Oh, I don't know what peering is.
Hello and welcome everybody. It's time to talk about VPC peering. What is it? VPC peering enables seamless communication between different virtual private clouds, expanding your network's possibilities, and also simplifies resource sharing. This is a very crucial topic for infrastructure as a service. Let us go ahead and break it down. VPC peering is a networking feature in GCP. This allows you to establish a low latency, highly available connection between the two VPCs in Google Cloud. This connection enables instances in different VPCs to communicate with each other as if they were in the same network. They use their internal private
This should be VPC network peering, I would think.
IP addresses to do so. It's like creating a virtual bridge between your networks. But why do we want to use VPC peering?
It would be creating a literal network bridge between your networks, which I guess a virtual bridge is what all of it is in the cloud, but okay.
Peering offers several advantages. They easily share resources hosted in one VPC with instances in another VPC. And all of this is done without needing complex routing configurations or even setting up public IP addresses. It's not required. You get network segmentation easily. You can maintain that. You can maintain separate VPCs for different environments, like you may have one VPC for development, testing, or production. But even though you have different VPCs, you can still allow communication between them. Then, hybrid connectivity. You can connect your on-premises network to your Google Cloud VPCs, enabling secure communication between your private data center and cloud resources. You also get reduced latency. Now, since traffic between the peered VPCs stays within Google's network, you benefit from low latency communication compared to using the public internet. Then VPC peering is really cost effective. You avoid data transfer costs associated with sending traffic over the internet when communicating between the VPCs. There are several key considerations, and we must chat about them. For example, VPC peering does not support transitivity. Peering is not transitive. So if you have three VPCs, let's say A, B, and C, and A is peered with B, and B is peered with C, that does not automatically mean A and C are peered.
Okay.
Also, make sure the IP ranges of your peered VPCs do not overlap to avoid routing conflicts. That means you should not have any overlapping subnets or overlapping networks, even on your premises. Security is important.
Now, that could happen if they are separate networks. Inside a network, you can't have two overlapping subnets. We tested that, but you could accidentally have overlapping subnets in different VPC networks. Okay.
Situation. Implement appropriate firewall rules and also the security groups to control the traffic flow between the peered VPCs. Always consider using a shared VPC if you want to centrally manage network resources across multiple projects within an organization. All in all, VPC peering is a versatile tool for connecting and extending your Google Cloud networks.
Yeah, okay, I get that. That's fine.
Hello and welcome everybody. This is a lab demonstration on creating VPC peering architecture. So what are we going to establish here? Well, there are numerous tasks, and let me explain them to you one by one. So the first thing to do is to create a VPC network.
Right,
Well, one VPC network will not be sufficient, so we need at least two to demonstrate VPC peering. So here in step number 11, as you can see, that a second VPC is also being created, and then we'll move on to task 3, which is about creating VPC peering connection. Once the peering connection is established, that means the status changes patient. So we need at least two to demonstrate VPC peering. So here in step number 11, as you can see, that a second VPC is also being created. And then we'll move on to task 3, which is about creating VPC peering connection. Once the peering connection is established, that means the status changes from inactive to active. The peering would be considered complete. So it means setting up peering is not difficult. Understanding.
Oh, yeah, hold on. Let's go there. That should be really easy. Network pairing. Oh, yeah, okay. That's not a big thing. Yeah, that I don't see that at all. What I'm curious about, though, is inside one VPC network, if I have two internal ranges. Can they ping each other? Yeah, let's do that. So, I could just use the default one to find out. Yeah, but that won't really help me because it could have already been set up and I want to know how to set up. So create a VPC network. Okay, we're going to call this PowersNet. Custom, yeah. This is going to be sub 1. It's going to be, let's see. A network is tied to a subnet. Okay. No, subnet is tied to a region. So US Central is going to be the first one, and it's going to have an IP range of 10.10.10.0.24. Okay. So that's going to be the first subnet. It's going to be in region 1. Okay, and then I'm going to add another subnet. There's going to be subnet 2. This is going to be in US East. Okay. And this is going to be 10.10.10. I bet this, it should tell me no. Oh, why didn't it tell me no? Maybe because I hadn't already created it, so it's not checking. But we're going to do that one 11. Oh, I didn't click done. Okay, that's done. And now this one, if I do 0, it should freak out, right? Oh, why didn't it freak out? Oh. So as long as they're in different regions, they can have the same. All right, well, that's a little frustrating. But if I make them different. Oh. And it automatically created all these rules. Okay. Let's see. Learn routes only in the region. Dynamically learn routes to and from all regions within a single VPN or interconnect. All right, we'll try it. What the heck? Okay, so PowersNet now has 2 subnets. Oh, and they exist in different regions. So when I create the... Okay. All right. Well, okay, hurry up and create the network. 2 subnets. Okay. Now let's go back to Compute Engine. Create an instance. Okay, gonna say region there. Okay. Zones don't matter in this regard, supposedly. So Central 1. And I'm going to do micro. I don't need much there. Standard provisioning. Yeah. Advanced options networking. Okay. Network is going to be PowersNet. And the subnetwork, why can't I? No subnets in this region? Why not? US Central 1. Isn't that what I chose? Okay. PowersNet. Subnet. US Central 1. Sub 1. US Central 1 region. Network is PowersNet. It does, though. But it does have a subnet. All right, maybe I'll have to select a zone. I don't know. A? No. Default. Yeah. PowersNet. Okay, I do, though. That's the thing. I have one in that region. Let's try US East 1. Down here, networking. PowersNet. Oh my gosh, but I do. Why can't I use PowersNet at all? Okay, let's look at default. That should be right. Region, yeah. Name is default. The region is there. Subnet. Name is there. Region is US Central. Maybe it just hadn't. Well, this is useful anyway, though. Assigns the instance to, okay. Instances in different subnetworks can communicate with each other using their internal IPs as long as they belong to the same network. Oh, that answers a question I was trying to figure out anyway. But what I don't understand is why won't it let me? It must just not have. It just must not have gotten there yet, right? It does have a network in that. Oh, boy. Okay, I'm thinking it just didn't populate it yet. Networking. Nope. Ugh, it just hadn't populated it yet. Sometimes I'll tell you what, you silly bear. All right. So even if they're in, yeah, because that should be the only one available. Yep. All right. Okay. Got it. And it gives me the answer right there. Instances in different subnetworks can communicate with each other using their internal IPs as long as they belong to the same network. And they do. Using their internal IPs. So they have to set up routing too. Well, that's because that's not how networking works unless there is a router, and there is a default route, so that it has to be setting up routing too, not just plain networking. Because if you have two computers plugged into the same network, meaning like plugged into the same switch in your house, which is kind of what a network is. I mean, it apparently not, but they can't communicate using different subnets. But this is saying that they can. And I'm going to test that so that I can explain that more fully. So E2 micro. Okay. We're in subnet 1. Perfect. I'm going to create you. And now we're going to create another one. This one is going to be in US East. And this is also going to be E2 micro. But this is going to have to be in a different subnet because that is how things work. And look at that, sub 2. Perfect. I love it. All right, create. And look at that. It tells me the internal IP address, and the next one should be 10.10.11.2 when it spins up fully. I hope. 10.10.11.2. Boom. Like a glove. All right, let's connect to this one. SSH in the browser using the automatic keys. So nice, so spiffy. Authorize. Oh, yeah. Let's see. When are you going to upload more content to YouTube? I miss your knowledge. This is part of me trying to get a handle on my schedule. Horizon 14. I think that's the username. In fact, my plan is, so I'm doing morning live streams as well, 7 a.m. Eastern on Tuesday, Wednesday, Thursday. My hope is that one of those days I'm actually creating content for my YouTube channel, and then I will upload them. So I'm trying to get back to more online content. My day job has been kicking my butt, and so this is just part of keeping me on track with my day job so that I can take the time to do the other stuff. But this morning in the morning live stream, we did look at like the next topics, and it's still going to be more like bash scripting stuff, which is the section we're on in Linux Plus. So the long answer that you didn't really ask for is I think actually pretty soon. I don't want to make a specific promise as to a date, but the machinations to make it happen are actually happening. So I consider that a win, sort of. So hopefully soon. So why is this taking so long to connect to? Come on, SSH server. Also, for what it's worth, this whole I'm live streaming while I work is really good at keeping me working. I think I probably would have been in a bout of frustration. I would have gone downstairs and gone to the fridge for something to snack on, which I don't need from a gut perspective. Whoa. Not using a cloud identity aware proxy. I wonder if that was me setting up the, let's see. Let's just do regional because it didn't say I had to do anything to make them talk to each other. Let's try to connect to this one. Oh, thank you, Horizon. I appreciate that. I truly, truly do. This is a little frustrating, though, that all of a sudden I can't seem to connect to my virtual machines. But if they're connecting via external IP addresses, I don't understand why or what I could have possibly done to mess them up. Hmm. SSH in the browser. Why? Please ensure the VM has a firewall rule that allows TCP ingress traffic from the IP range, port 22. Okay. I guess that would be in the network. See what it has external IPs. Is that still part of the networking that I have to do? I'm glad I'm doing this now. Or is that going to be in the subnet that I have to configure that? Let's see. That's the range. Yes, yes. Hybrid subnet. All right. I don't know what that means. Let's look at the default to see what. Okay. Subnets. Hybrid subnet is off. That's off. Huh. Okay. Why does this not work? Okay, back to default to see what it has set up. Those are all the subnet firewalls. Are there any firewall rules? Oh. Oh. So by default, I don't have any. And I need them. All right. All right. I see you. I see you, computer thing, not making it easy. PowersNet. Firewalls. Oh, wait. Is there? Oh, no, there's no firewall. So add firewall rule. Name is going to be VPC firewall rules because I like that. The things that come default on the default network. Enforcement order? I don't know. Okay. Ingress allow target specified tags, all instances. Right? Yeah. Let's see. Source. Oh, source ranges. Yeah. 0.0.0.0.0. Yeah, apply to all. Okay. IP ranges. Oh, yeah, IP4 ranges. Okay. Destination filter. Done. Yeah, no. No, there's no filter for destination. Oh, allow. Okay, I see. Allow TCP. Part 22. Targets apply to all. Source filters. Okay. TCP port. Okay, got it. This makes sense. Yeah, I right now just want to allow port TCP 22. But I guess I could do multiple ones, couldn't I? Yeah. And if I wanted to be able to ping it, ICMP. Okay. Can I? Oh yeah, I can just allow ICMP. Okay. This is working. Look at how much I'm learning. I'm learning so much. Global. Ooh, what happened? Oh, no. There. TCP. Allow. All right. Okay. No. Retry. Okay. What is this IP address? This one is the, okay, so now if I do ping 10.10.11.2, look at that. Even though it's not, it does set up automatic routing between subnets inside a network. Well, I am such a happy camper. I feel like we have just made awesomeness happen. But I'm going to go back in and so if I were to change it so that it did not allow ICMP, how do I edit? All right, so not ICMP, and save that. Does that only prohibit external? Oh, how do we get back to here? Oh, it's applicable to these. Okay, so now, have I blocked it? Oh, that is so sweet. So the firewall rules do apply to that internal stuff, but I can still, like, I should still be able to SSH to it. 10.10.11.2. Yes. Oh, permission denied. That's fine. I don't have a public key. And I probably didn't turn on the ability to log in with a username, but that is stinking awesome. Okay. All right. It's going to be a good skill. let's get out of here. Exit. Yeah, fix that. Fix that so that can all go away. And now, something I learned the last skill, I need to clean up after myself now. So, here. Ka-chow, ka-chow. Need to delete both of these. And not firewall policies. Oh, this was for wait, how do I know what firewall policies and what? What is NG? Total networks 2. Total network firewall policy 0. I don't know what that means. Oh, network security. No, that's not where I want to be. Okay, I don't know what I did here. I just wanted. Okay, I don't know what network security is. No. No. Just VPC network. That's what I wanted. There we go. All right, now in here, I can delete this VPC network. Ah, I love it. Cleaned up, so I'm not incurring any costs now either. I mean, I wouldn't have with the network, but all right, sweet. Hey, Bjorn, can't be right. I'm on YouTube. I mean, yeah, that's okay. You're welcome to join from anywhere. Welcome, 34 minutes late. That's all right. I'm just streaming my workday, so no harm, no foul. And I actually, while it's been a lot of really awesome things going on, I do have to use the restroom. So I'm going to, let's see, I think this will work. I'll be right back as soon as I use a bathroom. All right, I tried a different chair. It's a little lower, but it's more comfortable. I don't know. It'll be fine. I'm not recording quite yet anyway, like for work. So it's fine. The chat is ready to display messages. Oh, does it reload the chat every time? Well, that's weird. Oh, yeah, don't shut down the source when not available. All right. Okay. All right, I think it's good. All right, sweet. All right, we're back. Already up to 47 out of 50 followers on Twitch. That's incredible. So thank you to everyone. Oh, and I'm going to take a break and eat this popsicle. So let me get my scissors. Totally deserve a break. Ugh, shoulders really hurt. I don't know if it's, I have this swapper chair. It's like, it's supposed to help with like posture and balance, but it really hurts after a while. So I don't know if it's a good thing or a bad thing. So I just got my regular chair, which doesn't go as high. So that's why I'm kind of lower here. So I'm feeling pretty good about this skill. I'm going to start with the network service tiers, then talk about virtual VPC networks, not just virtual private cloud, but virtual private cloud networks. Bjorn has a swapper chair. I like it, but it hurts my, I don't know. I don't know if I sit in it wrong or something, but it hurts my back after a while. I am used to it. I mean, I've had it for years and it's always at this desk, but I think I might just be like hunching too. Like while I'm sitting in it, I'm also like hunching over and read. I don't even know. Maybe I'm just getting old too. That could be. But this chair won't work. It's too low. But I'll just take my break and eat my popsicle. And then I'll swap back to the swapper chair. But anyway, with this skill, I'm feeling pretty confident about it because talk about network service tiers, then talk about virtual private cloud networks. And everything now is a virtual private cloud network. Talk about the default and how each region has its own subnet if you do auto mode, and how each subnet, as long as it's in the same network, can communicate with each other, which is different than if you were just to set up two subnets at home. I think that's important for me to point out, because if you're a networking person, just having two separate subnets on the same network doesn't automatically route traffic between them. You have to have something routing traffic, and there Google's clearly doing that, even though they don't call it routing. Inside the networks, they are routing between subnets. So that's important to note. Now, of course, the subnets have to be set up, whereas, yeah, so I'm just going to point that out. And then let's see what else. Oh, then I have to learn about load balancing, which is what I don't think, though. I don't think I have to do a ton of crazy in-depth stuff about load balancing, because they just talk about, like in those two things that I downloaded. Let's see, not capture scratch. Let me get rid of all this. But let's see. Why is that still there? Refresh. Okay, it's empty. CPT, ACE, 2.3. So yeah, I have a virtual private cloud offers a suite of load balancing options. So they call it 5 different types. And I think I just need to explain the different types. I don't think we have to actually set them up. I think that's going to be more than is expected. And then the summary of these, this shows 6 here, only 5 here. Regional, internal, regional. Yeah, these are different names, so I don't understand. External. Okay, so global. This is a weird chart. 80 or 80. 80 and HTTPS, okay. And then SSL proxy, TCP with SSL offload. SSL offload. So where is the SSL happening? Has to be some sort of a front end. TCP proxy. Okay, does not preserve client IP address. Oh, that's interesting. It does not preserve the client IP address. Okay. Then we just have a network proxy where this is just layer 4, network TCP, UDP. Okay, without SSL offload. Can do any. Then internal HTTP. Or HTTPS on 443. All right. Again, it's just kind of weird. So layer 7 load balancing based on load can route different URLs to different backends. I guess that's nice. I mean, that's just like when you set up rewrite rules in like Apache. And if you do proxying with like Caddy, you can set up different rules based on the URL. Hey, Tia. That's my sister, everyone. Thank you. I appreciate that. So if you're wondering, once I start teaching, this bottom window will be where I do slides. This is my Wacom tablet down. Whoa, what did I do? Oh, it minimized everything for me. That's weird. That was really weird. Anyway, yeah, that bottom screen is where that's my Wacom tablet. So like when I'm demonstrating stuff, I'll be writing on that. As soon as I'm done with this, I'll actually start. I'll add coffee. If you were watching earlier this morning to the live stream, I did not have any coffee, which was terrible. But coffee arrived, and so I've been drinking afternoon coffee because I really missed having coffee. All right, maybe I'll watch a little bit of this VPC peering. Should I even mention that? I mean, it's not really mentioned in the what would be I guess I could mention VPC peering. Yeah, I will. Maybe if I need to. depending on the time. Needed text video. So I usually just make an outline so I don't forget any of the things I have to put in my skills. Okay. Not going to talk about that.
Hello and welcome everybody. In this section,
Yeah, thanks. I know what IP addresses are. What are you talking about
If a
here?
network is a legacy network, the IP address is assigned from the network's global internal IP range. You can address packets to a VM instance using an internal IP address of the instance. Compute Engine supports two types of internal IP addresses: static internal IP addresses and ephemeral internal IP addresses. Static IP addresses are assigned to a project long-term until they're explicitly released. They remain attached to the resource until you have to explicitly detach them. In virtual machines, static internal IP addresses remain attached to stop instances until they're removed.
Yeah.
Ephemeral internal IP addresses
Are
are available to VM instances and forwarding.
All right, back to load balancing.
The pass-through network load balancers is the next one. Cloud load balancing service of Google. Let's quickly understand what load balancer is. A load balancer distributes user traffic across multiple instances of your application. By spreading the load, load balancing reduces the risk that your applications experience. Google's cloud load balancing service essentially acts as a traffic director distributing incoming requests across a pool of backend servers in your cloud environment. It is built on reliable, high-performing technologies such as maglev, Andromeda, Google Frontend, and Android. The same technologies that power Google's own products. Cloud load balancing offers two types of load balancers: the application load balancers and network load balancers. Let's explore them in depth one by one. First, the application load balancer. Application load balancers are proxy-based layer 7 load balancers that enable you to run and scale your services behind an anycast IP address. The application load balancer distributes HTTP and HTTPS traffic to backends hosted on a variety of Google Cloud platforms such as Compute Engine and Google Kubernetes Engine, as well as external backends outside Google Cloud. Application load balancers can be deployed externally or internally, depending on whether your application is internet-facing or internal. The second type is network load balancers. Network load balancers are layer 4 load balancers that can handle TCP, UDP, or other IP protocol traffic. These load balancers are available as either proxy load balancers or fast-through load balancers. You can pick a load balancers depending on the needs of your application and the type of traffic that it needs to handle. Let's look at the proxy network load balancers. Again, as I said, these are layer 4 reverse proxy load balancers that distribute TCP traffic to virtual machines instances in your Google Cloud VPC network. Traffic is terminated at the load balancing layer and then forwarded to the closest available backend by using TCP. These load balancers are implemented as managed services on GFEs. The pass-through network load balancers is the next one under network load balancers. These are again layer 4 regional pass-through load balancers. These load balancers distribute traffic among backends in the same region.
Okay. Client traffic. Okay. Yeah. Pass through. Oh, it can go external to Google Cloud too. So a proxy network load balancer is for, yeah, TCP traffic. Direct server return. So they get a response. It doesn't go back through. It goes directly to the, how does that work?
As a load balancer. They are implemented by using Andromeda virtual networking and Google maglev technologies. As the name suggests, these load balancers are not proxies. Load balance packets are received by backend VMs with the packet source and the destination IP addresses protocol. And if the protocol is port-based, the source and the destination ports are unchanged. Load balance connections are terminated at the backends. Responses from the backend VMs go directly to the clients, not back to the load balancers. The industry term for this is direct server DSR. To determine which cloud load balancer product to use, you must first determine what traffic type your load balancers must handle. Let's explore the important features of cloud load balancing. Single anycast IP address. With cloud load balancing, a single anycast IP address is the front end for all your backend instances in the regions around the world. It provides cross-region load balancing, including automatic multi-region failover, which moves traffic to failover backends if your primary backends don't handle it. Then seamless auto-scaling. Cloud load balancing can scale as your servers and traffic grow, including easily handling huge unexpected and instantaneous spike by diverting traffic to other regions in the world that can take it. Auto-scaling does not require pre-warming. You can scale from 0 to full traffic in a matter of seconds. Then we have software-defined load balancing. Cloud load balancing is a fully distributed software-defined managed service for all your traffic. It is not an instance-based or device-based solution, so you won't be locked into the physical load balancing infrastructure or face the high availability, scale, and management challenges inherent in instance-based load balancers. External and internal load balancing. You can use external load balancing when your users reach your application from the internet. You can use internal load balancing when your clients are inside the Google Cloud. Global and regional load balancing. You can distribute your load balancer sources in a single
Hold on, I got another person who is who's spamming, and that is something up with which I will not put. All right. Creator dashboard. Stream manager. My chat. Here I can. No. Somehow there's a way I can. How did I do this before? Yeah. Well, doggone it. Okay. No. I want to. Well, somehow. How do I get rid of that? All right, somewhere. How do I? Is it clear that I am not a professional Twitch person yet? I don't care about stories on Twitch. Somehow I did this before. How did I do it? I am a moderator. All right. But how do I mean, I got to think I'm a moderator on my own channel, right? I thought I had 3 dots on this the other day or earlier today. No. Do not display the mod icons. I don't know. Is that in settings? Chat settings. Show mod icons. Oh, there. Maybe that's it. Oh. Delete message, and I can timeout. I can ban. Thank you very much, Bjorn. I greatly appreciate that. Thank you. Oh, and banning them deletes it and gets rid of it. So, perfect. Thank you. All right. Cool. I feel much better about that now. I don't know where I saw that before. Like maybe it was toggled in a different location or something. I don't know, but thank you. You're right. That is all it took. Or maybe I like went into the user and that's how I found them. Like if I click on the user, maybe it gives me more information. I'm not sure. I don't think there's anything I can do here. Oh, I can add to block list and restream chat. All right. I don't know what that means. All right. This is too short. I feel like a little kid. Oh, well. So this is a swapper chair. It's got like a spring. It goes up and down. It's supposed to be good for your posture. But it like bounces and I can spin. Good for my core, apparently. I don't know. But nonetheless. Okay. I guess let's watch a little more.
or multiple regions to terminate connections close to your users and to meet your high availability requirements. And finally, we have advanced feature support. Cloud load balancing supports features such as IPv6 load balancing, source IP-based traffic steering, weighted load balancing, WebSockets, user-defined request headers, and protocol forwarding for private virtual IP addresses. Let's understand how the load balancing works in GCP. Users trying to access your applications and requests which hit the cloud load balancers first. The load balancers acts like a smart traffic cop. It analyzes the incoming request and chooses the most suitable backend server from a pool you have defined. Now, the backend pool is a group of virtual machines or container instances running your application. The load balancer distributes traffic among them. Selection of algorithm is also very important. The load balancers uses a chosen algorithm like round robin or least load to pick the best backend server. This ensures even this.
Oh man, I really hate training, and I know that that's rich coming from somebody who is a trainer, but it just drives me nuts. So I'm going to see if I can just figure it out. Let's go back into Compute Engine. Let's make a couple instances again. I should have just left them. All right, create instance, one in Iowa. I'm just going to leave it the default. And then one in US East, one. South Carolina. That's a micro instance. Create. Now I think when I have two, yeah, what is this? Set up load balances. What a nice little shortcut. I like that. Where will that take me? Oh, okay. Load balancing. Balancing and auto-scaling for groups of instances. Oh, for server-side load balancing, distribute incoming traffic from multiple virtual machines. Yeah, scaling. Okay. Yeah. Forwarding rules to match certain types of traffic. So, oh, I don't need auto-scaling. I just wanted load balancing for what's there. How to choose a load balancer. Okay. Oh, yeah, look at this. So there's definitely two. Okay. We're going to certainly have to talk about that there are two types of load balancers. All right. Explain the difference there. Maybe I might even just use the Google. I don't love that. I like, since I'm teaching Google stuff, I don't feel terribly bad about just using their diagrams. I don't know. Maybe I'll get scolded for it, but save as application load balancer. Do. And this is going to be a network load balancer. All right. Okay. Global external application load balancer support 2 modes. Global external application. So that's over here. Global and classic. Okay, what's the difference between classic and regional? I don't know. Global external proxy. Global external proxy network load balancers. Oh, proxy network load balancers support 2 modes, global and classic. Okay. Pass-through network load balancers preserve the client source IP address. Pass-through network load balancers also support additional protocols like UDP, ESP, and ICMP. Yeah, okay. To decide which load balancer best suits your implementation. Yeah, so this is why my shoulders hurt. I'm looking down. I should be looking like straight up, but I'm not. And my camera's here. Well, you can't see. My camera's here. And I can't put my camera here. Although, wow, maybe I should. I'd have to do a whole lot of change. I mean, I could just put everything lower. I could just... Let's see, what are the implications of that? If I made myself a little lower so that the screen was actually in front of me where it's supposed to be instead of down, I would be lower. I would have to adjust the camera down. I guess that would probably be better though, wouldn't it? Okay, let me... Apparently I'm taking a little break here again because I'm hurting and that is not ideal. So when I'm typing, I should have my arms at like a 90-degree angle, which is about what they are right here. Actually, no, even a little lower. Oh, I'm all the way down. Okay, so this is all the way down in this chair. But OBS, with OBS, I'm a little bit too low, but I could, wait, this is 4K, so I could probably face cam, no, that is full size, so just face cam is here, raw face cam. Apparently it's not 4K. Okay, so I just manually tilt a little bit. Oh, 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 this feels like I'm making bad choices. Okay. Okay. A little bit more. No, I'm still not. All right, that's good. Okay, this has to go lower now. And that is too far that way. Okay. There. Oh no. Shoot. Man, that is just really on the, like, so, ugh. See, the issue is, I don't know if you can, oh, you can't see oh, yeah, you can kind of see. So on the corners, like right here and right over here, I can almost see the bottom of those things, and I shouldn't be able to see that. Yeah. All right. But I think height-wise, I'm good. So this can come down a little bit now. Check, check, check. Yeah, that's still good. All right. It's centered here. All right, I think this is good. Oh, now I can move this down a little bit, I suppose. It's a whole different camera system for the live stream. Oh, where does that put? Well, I don't really use this anyway, do I? No. All right. Hey, look, now I'm advertising. All right. So this is good. This is good. Left slide's good. No face slides. My face. My big face. Wow, wow. All right. Bjorn, I don't know how long ago you left that message. Sorry I missed it. But the funny thing is my desk that you can normally see behind me, but is now covered by the screen, is actually a standing desk, but it's like all the wires and stuff are not so that it can move up and down. Like the camera settings and like all the different wires that are coming on and off the desk, none of it is set up so that it would comfortably move up or down. Like the lights, I have lights all over here. I'll show you. So like the lamp that you can see back there and all the stuff in like the hair lamp or the backlight, which is in the top of the bookcase behind me for my other desk. If I use it as a standing desk, when I stand up, nothing lines up. And then the background, if, you know, when the camera goes up, the background images are like just the ceiling instead of like all the stuff behind. So yeah, I just, I sit down over there, but it is a standing desk. This setup is this tiny little desk that, actually my daughter bought and then didn't use. So it mounts directly to the wall, and it's only like probably 18 inches deep and just enough room for my monitor, my Wacom tablet. And I had to actually add a rollout or a slide out keyboard drawer underneath. But yeah, it's right up against the wall. It's not a big office, and I have 2 full studio desk things on it. So yeah, so I'm not complaining, but yeah. Ooh, all right. So where were we? Oh, learning about the different traffic types. Okay. Sorry, back to learning. Traffic type, external versus internal, global versus regional, premium versus standard network service tiers. Right. Oh, I guess that would matter. And proxy versus pass-through load balancing. Okay, what is? We deploy an external or internal? External load balance, distribute traffic that comes from the internet to your Google Cloud APC network. Yeah, internal, distribute traffic that comes from clients in the same. Oh, I guess so. That's like if I have a bunch of back-end processes, I can scale internally. Right. Okay, that makes sense. That's not as big of a deal as I thought. Any clients are internal or external. You might have the option to choose between either global load balancer or a regional load balancer. Choose a global load balancer or cross-region load balancer when you want the load balance to be distributed globally or span multiple regions. Such load balancers can also distribute traffic to backends across multiple regions, making them suitable when your application or content is distributed across multiple regions or when you want the flexibility to add multi-region backends as your application grows. Yeah. Only external load balancers are available for global load balancers. Okay. With backends in multiple regions, choose a cross-region load balancer. Okay. Cross-region load balancers provide access by using regional internal IP addresses that come from the regional subnet. Yeah, that's different from global load balancers, which provide access to a single anycast IP address. Oh. Okay. Choose a regional load balancer when you just need backends in one region only. You require only IP version 4 termination, or when you have jurisdictional compliance requirements, traffic to stay in a particular region. Oh, okay, that's good to know. Workloads that require regionalized resources for compliance reasons mandate that certain resources must be kept in a specific region or require traffic to be terminated in a given region. All right. A regional load balancer is deployed in a specific region. All right, that makes sense. All right. Regional. Okay, now it's just given our region affects the regional load balancer in that region. Yeah. But regions so rarely go down. What is the summary table? Okay. There's so much to cover here. Just go down. So, application, yeah. Pass-through network load balancers, TCP or UDP. Also support ICMP and stuff. Okay. Proxy network load balancers, TCP with optional SSL offload. Okay. I gotta think SSL offload just means that SSL is handled at the front end anycast IP or any IP, whatever they called it. Determine which load balancer works for your application. Use the summary table. Global versus regional load balancing. Load balancing or cross-regional load balancing when you want the load balancer to be distributed globally or span multiple regions. Yeah. Okay. Proxy, terminate incoming client connection at the load balancer and the new connections from the load balancer and open the new connections from the load balancer backends. Okay. Work this way. They terminate client connection in our Google front ends or Envoy proxies. Yeah. Pass-through, don't terminate client connections. Instead, load balance packets are received by the backend VMs with the packet source, destination, and if applicable, port information. Connections are then terminated by backend VMs. Responses from the backend VMs go directly to the clients, not back to the load balancer. The term for this is direct return. Use a pass-through load balancer and you need to preserve the client packet information. The pass-through network load balancer. Okay. Proxy-based load balancers and send connections to the backends and different. If you are using the form, then let's keep track of IP address and expect the same IP address the second you might not to use a proxy. Proxy load balancers don't preserve the client IP. This type of authentication is more compatible with pass-through. For proxy load balancer, But what I don't understand is with the pass-through load balancer, the client connects to like an IP address or to a DNS name to the back end, but then how does then it returns directly from the back end, but that's going to be a different IP from where the client connected? So that seems like it breaks stuff. Network service tiers let you optimize connectivity between systems and the internet. Premium tier. They really choose premium tier for high performance. You can choose standard tier as a low cost alternative. Premium tier for IP address. Load balancers and the premium. Traffic traversals, yeah. We don't specify load balancer defaults to premium. Yeah. If the IP address of the load balancer is in the standard tier, the traffic enters and exits the Google network at a peering point. Not all load balancers can be deployed. Oh, let's see that summary table. Oh, network service tier. I'm going to sneeze now. Hold on. Oh, excuse me. Right, well, that would require, that makes sense. Okay, and then proxy network. So premium tier is required for internal traffic, but you don't get charged anything extra for that anyway. So that's a moot point, I guess. Tester network load balancers. Yeah. Oh, pass-through is always regional. I guess it would have to be because it's going to the, yeah, okay. All right. All right, another. All right. Yeah, this is going to fill up a skill quite easily, I think. So I probably won't need the VPC peering, but I'm going to leave it there just in case. Losing people on Twitch. That's all right. It's not terribly exciting. I get it. I could. Hold on. Let's. What is that thing called where I can do messages? I forget the name of it. That's all right. So in my attempt to continue to get more Twitch viewers at the same time, Anyone with an idle, which it changed to with Annie. Anyone with an idle connection who wants to watch me work on Twitch is encouraged to do so. Twitch.tv /Sean Powers. All right, cool. So proxy network versus paths through network load balancers. Yeah. That's not as useful as I thought it would be. No, okay. Where was I? Was I over here? Ah, here's where I was. Okay. External unspecified names. Oh, yeah, okay. So these are protocols and then backends. Backends can be in multiple regions for application load balancers. It makes sense. Proxy load balancers. Okay. Pass-through cannot be in multiple regions for these. Okay, that makes sense too. Virtual machine backends and compute engine works for everything, which is great because that's what I'm going to use as my test case. All right. So on those two, okay, so if I set up a website, what I don't know is if, yeah, these are two different internal things. These are their external. What I don't know though is if all right, so there now I have to update. So I could obviously set up just a web server to test the various things. I guess I could, the same web server could work for the other types of proxying. I could just set up, it doesn't have to, like I could do a pass-through to port 80. That would be fine. So yeah, okay. I'll have to install Apache 2 because I think this is Debian. Yeah. All right. Okay, so it does enable it by default, but I don't know if it starts it by default. Let's see if we go to oh, you know what? I bet I don't have firewall set up for it to allow that. System CTL status Apache 2. It's enabled and it's active. Okay. Okay. All right. About firewall. Ah, okay. All right, cool. Save. Boy, it's taking a long time to save. Do 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 do. Bum 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 ba-dum, bum bum ba-dum. Okay, so now this should display. Aha, there we go. Okay. Let's do the same thing. Now, what I don't know is I probably don't have to like set this up with. Maybe I'll just show it during the demos. Edit firewall. Boom, boom. Save. Okay. Let's see. This one is 40. Oop, 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 oop. 43 is central. Okay, so etc. No var www html and rm. Title is Central US. Title. Oh no. All right, need some simple HTML. All right, cool, cool, cool. Oops. All right, let's see. Okay. So that is that instance. Now over here. Oh no. Why can't it connect? I thought I set it up. 45,137. Yeah. Oh, I didn't. I didn't install Apache. That's why it's not responding. So right now I'm just installing Apache on these two different ones so that they show. I'm hoping that when I do load balancing, I can show that it'll go between them. That's my hope. Oh, yeah. Okay. Mm. Um, hmm. Well, apparently I've only learned to do it in PHP. Okay, and install. G2 PHP. Okay. 22 mod PHP. All right. And now I'm just making several different, there's a lot of work actually going into this, but all right, where is the eastern? Is that Georgia? I'm getting tired. Iowa, no, east is South Carolina. All right. Okay. Okay. Frustrating part is I'm not even sure this is going to work. Okay. Okay. So we have those two. Now, what if we went to, is Cloud Load Balancer load balancing? Okay. Oh. We can. Oh, what are front ends? Never done this before. So first we'll do an application load balancer. It's going to be public facing. If you have clients distributed globally, single region. Oh no, I have two different regions, so I need global. Global external application. External managed load balancer scheme or yeah, we can do classic, but we'll just do the most recent one. All right, I'll configure it. Configure the load balancer's front end IP address. Cool, cool, cool. Oh, I could create a new certificate? No. No. Port 80. Yeah. Done. Oh. Oh, I need to name it. Okay. Which test front end? No, we went to a health check. Oh, apparently I have to do a health check. All right. All right. Routing rules, simple host and parent. Do, 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 do. Hey, D Powers is my wife. Hello. Thanks for tuning in. I'm just doing, you can see I'm actually working. So, yeah, Donna, if you thought that I wasn't working, I'm working. This is proof. Actually, I think this has kept me working really well because otherwise I sometimes get distracted. But now if I get distracted, I feel guilty. All right. Boy, it's taking a long time to create. I hope it's working. Make sure it's still working. Okay. All right. It's there. One back insert. Okay, why didn't it? Oh, there we go. So, try to go here. Copy this. Oh, well, it didn't work. What did I do wrong? Okay, backend services there. Oh. Oh yeah, it didn't actually. Oh, I have to configure it back in then. Okay. So how's that different? Backend configuration. Only backend services. Okay, that's fine. I don't want that. Backend services and backend, okay. That's what I want. I guess I have to add a backend. Guess I don't have an instance group. What is an instance group? Okay. Well. VM instances, instance groups right here. Okay, instance groups. Create an instance group. Two webs, we're going to call it. Two web servers. Oh my gosh. Global. Wait. No, I don't want that. Wait, I don't want. No. No. I need an instance group of these two. Create a group based on this VM. You must select exactly one instance. I want two. Boy, it's good I'm doing this. Okay, I don't want this. This is not what I want. New backend. What if I don't want that? I don't want an instance group. Okay. Add a backend. A managed instance group is a group of virtual machine instances that you control as a single entity. MIGs support features. Manage groups of load balancing. Hmm. Okay, that's not going to work like I'd hoped. Hmm. Crud. So load balancers have to specifically run the exact same thing, which I mean is nice, but it makes it difficult to show that it's working. What if we just did a network load balancer? Is that going to be different? Oh, ba-da-bum-bum-bum. Hey, I assume that is my son-in-law. And hello. All right. Oh no. Darn it. Oh, it didn't work because oh. It failed because I deleted stuff. All right, we'll try it again. We're going to do network load balancer. We're going to do proxy. We're going to do public facing. It's going to be global and it's going to be that kind. Sure. All right, we're going to try this again. Test. Backend type is going to be a hybrid connectivity. Okay, the backend to create a network endpoint group. Forward. Okay. Okay. All right. Trying to create the load balancers. All right, Neil's also working. Well, we can work together, buddy. Mine is pretty boring. You get to talk to people. I get to talk to people who aren't there. I mean, I'm talking to you and you're there, but like when I'm recording, I'm literally talking to people who are just not present. They're just not there. Right now, I'm trying to set up a load balancer, and it's complicated. But I'm hoping that this works because I think it's a great demo. It's taken a long time. It didn't error out, so I'm thinking that's a good thing. Ooh, you sold a car? Dude. Nicely done. Nicely done. So pretty soon, I mean, I know you've been working there for like what, 3 years or so? 4? I don't know how many years you've been working there, but I gotta think you're getting close to the point where people start rebuying cars you know, so like they'll come back when it's time to get another car, and I'm excited for you. 2020. So okay, I gotta think it's still like I gotta think it's coming soon, right? Like where you get some, you probably already had a few repeats, but I mean where people, you know, they drive a car until it's time to get a new one and then they come back to get another one from you. That's my hope anyway. Oh, it says one back end service is unhealthy. All right, well, let's see if this does anything. All right, well, my load balancer isn't working. Okay, so healthy is 0 of 2. All right, let's see what's going on here. Hmm. So why is that working? I thought that should do it. Network endpoints. All right. All right. All right. Well, what is? Hold on. Where's my? Okay, nope, that didn't do it. I want to. Okay, cool. All right, so back to network services, load balancing. Okay, why aren't any of them healthy? Hmm. All right. Dun, 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 dun. All right, you keep saving, buddy. Network and group. Protocol. Why does it not see it as healthy? All right, so the back end protocol TCP. Hmm. Apply functions to. Okay, let's try this now. I'm still not convinced it's gonna work, but that's okay. Mhm. Good instances. Yeah. Not bad. Okay. Hmm. Oh, no port mapping. No, 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 no. Oh, 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 oh. No. Oh, excuse me. Boy, oh boy. I have to be in the same zone. That doesn't seem great. Let's see. This is really not fun. Dun, 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 ba-dum, bum, bum. The proxy servers implementing around. I do not understand at all. It's very frustrating. Okay, well, so far. Ugh. What do we have for backends? Backend service regional TCP. I don't know. If this doesn't work, I'm going to give up. It's almost 5 o'clock. Ugh. My goodness. Oh, Neil, how's the balancer loader thingy going? It is going frustrating, but that's all right. It's how I get smarter. I love that the family is here, helping me get to affiliate status. All right, let's see. This load balancer thingy is working. Then I should be able to go to this website. But it doesn't look promising. Healthy. Wait, why 0 of 0? Oh, wait, it says one of two are up? Wait, it worked? Oh, whoa. I think it worked. All right. Actually, no, come on. What was the other one? Apache. All right. All right, let's see. All right, I think we're getting close. I got one of them to work. Okay, let's see. 5 seconds. Let's see. Seven. Oh, shoot. Okay. Yeah, that's not quite right. I gotta. So much effort. There we go. I'm instance 2. I'm instance 1. Okay. Now. 2 of 2 are up now. So if we come over here. There we go. All right. got it. Think I got it. Do 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 do. Hurry up and make the load balancer for me. I want to see it work. Whip dee dip dee dee. Now, let's see. What was the... All right. Load balancing, yeah. Submit. All right, cool. Wow, it's still not ready, huh? Well, you just keep on doing your thing. Just keep on going. All right, I am going to use the bathroom real quick. All right, I'm back. Back. All right, if this one works, I'm going to call it a day. Let's see. The IP address is there. Does not look promising. Oh. All right, so let's see, why didn't that one work? External. Okay. Says all services are healthy, but is that what I'm using for this one? External? Oh no, I'm using instances for that one. All right. So 87. Okay, yeah, what's this one? 76. All right, this is a hybrid connectivity network input group. Hey, I'm going to call it a day in just a minute. It's driving me nuts. It's driving me bonkers. And I don't know what the deal is. And I don't like not knowing what the deal is. Because my deal is knowing what the deal is. That's my deal. Okay. Because I don't get, so the back end configuration, TCP port there. Yeah. Yeah. There it is, the thing. Okay. Health check is up. Affinity. No affinity. Local was round robin. Yeah. Front end configuration. And that is the whole thing. Yeah. Standard network tier. Oh, okay. I mean, it doesn't matter. Proxy protocol is off. I guess I don't know what that means. I just don't understand. What's the deal? This load balancer is working. This load balancer is not working. So this one is a pass-through, and it uses network endpoint group of instances. Okay. Well, so the backend zonal network endpoint group. Yeah, this one is oh well. Yeah, I'm gonna call it quits for today. Just gonna leave those services running though. If anybody's still there, and I see a couple people are, thank you. I don't know who's watching on YouTube. I can't tell who it is, but anyway, thanks for tuning in. I'm gonna do, of course, I'll be there in the morning for the morning chat at 7 a.m. Eastern, and then I'll probably do this again tomorrow because it's kept me on task. But I'm just gonna go bonkers here. So yeah, have a great evening, everyone. Thank you for being a part of this.